Hello everyone. It's a pleasure for me to present the REMIGEN program dedicated to new breeding tools in the context of climate change, and I will focus on the first results that we obtained, that is the studies on heat-tolerant traits and the study of the impact of heat stress on the performances of dairy cows at the population level. So this presentation was prepared with my colleagues of INRAE and IDEL from France, INIA and IRIA from Spain, and Wageningen University and Research in the Netherlands. So the aim of REMIGEN is to provide breeding tools, and mainly in dairy cattle, to improve the efficiency and the efficiency in the context of climate change, and to maintain the genetic diversity. And within this program, we have a lot of different competencies, so quantitative and associated to work packages, so quantitative genetics to study the heat tolerance traits and the management of genetic diversity. Epigenetics in order to better know how genome and epigenetics shape the phenotypes. So with the build of an EpiChip, that will be able to be used in on-farm and some experiments. And the study of new breeding technologies, and more particularly genomic editing, in within species and between species, and this with the help of human social sciences, in order to evaluate the social acceptability of the new breeding technologies and of breeding strategies in general. So there are 18 partners of 9 countries, so I won't describe all of them. And as I said, now I will focus on one part of the subject, that is the measurement of the impact of heat stress on the performances of dairy cows, in order to define in a second time some traits related to that. For that, we used the existing large-scale national data. I mean, the phenotypes and the pedigrees that we use in the genetic evaluations, and the weather daily records associated to each herd. So in the first time, the studies were done within country separately, using the same approach, and this for production, health, and reproduction, so udder health and reproduction. And then in the second time, we compared the results. So you may have seen some presentation in the session 55 on the traits that we obtained, and of a meta-analysis at the individual level during the interval meeting. So we have 5 populations, so 3 Holsteins in the Netherlands, in Spain, and in France, and 2 local breeds, Montbéliard in France and the MRY in the Netherlands. The performances that were used are the test day records on milk, fat, and protein yields, and somatic cell count, and the conception rate at after the first AI. The period that was covered by this study varied between 5 and 11 years, depending on the country, and we had from 10,000 to 7 million of cows, depending on the population. So the daily weather information were provided by the national meteo agencies, and they were associated to each herd according to the zip code. We had different parameters, and finally we used the THI, which is a combination of temperature and humidity. So to study the effect of variation of THI on the performances, we studied each lactation separately, and we analyzed the performances using a model in which you have at each time the THI effect as a fixed effect. Some other fixed effects to describe the environmental effects, the genetic value of the dam, of the cow, a perm and for production and somatic cell count, a permanent effect since we have several performances per cow. So we tried several parameters, and finally for THI, the THI was defined as the average of THI within 3 days before the test day, so including the test day and the 2 days before for production and somatic cell count. And for consumption rate, it was the 8 days after AI, so including the day of AI. So the effects, the other effects were defined by each country, so most of them are very common, but they are not associated by the same way. Yeah. And now I will present some results that we obtained in first lactation. At each time, green is France, orange is the Netherlands, and black is for Spain. The dotted lines correspond to the local breeds, and the solid lines for Holstein. And you see here for milk yield that at each time we have a break point and after a decline, but that this break point is not the same for all the countries, with a break point which is lower, much lower in France than in the Netherlands and than in Spain. And after you observe a decline of about 60 to 80 grams per THI in each country, and for the here a steeper decline that we could observe, of course, in Spain and not in the other countries, because we had very high THI in Spain than in the other countries. So we have to wait for several years, and we will be able to estimate that even in France and in the Netherlands. So these temperatures, so when we translate to temperatures, it corresponds to moderate and low temperatures. So beware that it's daily temperatures, including also the night. But however, it is much lower than heat waves that we recently had, for instance. So here, the situation for fat and protein yield, you see that we have about plateau and then a decrease. And again, the threshold is lower for France than for the other countries. And after, so we have a steeper decrease at the end, yeah, and more marked for proteins than for fat yield. For somatic cell count, we have an increase of somatic cell count, which is negative, which leads to more mastitis, and which is more pronounced in France than with a threshold that is more pronounced for France than in the other countries. And finally, here you have the results for the conception rate, with decrease after a threshold which is more homogeneous between countries, between 61 and 64. And after, so when you see the slope, it's a big slope here, with about a loss of 1.3% of conception rate per point of THI for the Dutch and the French Holsteins. So to sum up, we observe a negative impact of increasing THI for all performances, which is more pronounced for production and for fertility. For instance, for France, an increase of THI of between 50 and 70 corresponded to 6 to 11% of the daily production, and the same increase corresponded to 10% of loss of conception rate for the Holstein in France and in the Netherlands. For production and somatic cell counts, we observed some differences in thresholds more between countries than between breeds. So this surprised us in the first time. But in fact, there are many different explanations, such as the farming conditions and the exposure to outdoor temperatures. So in France, a lot of farms a lot of farming systems are based on pasture. So the cows are going outside and are exposed to these temperatures, which is not the case in most of the cows in Spain. And in the Dutch situation, the farms, so the cows that were selected for the study were cows coming from the biggest farms, so that probably are less exposed to outside temperatures. Another thing is the pasture also, because for France, in the particular case of France, where the moderate temperatures correspond to spring, which is a period of changing of systems, of feeding system, which have an impact on the performances, and that is probably confounded with the THI effect. So, and in Spain, they have a strong experience with high temperatures, so probably the barns are better equipped to mitigate heat stress. So all these things should be confirmed, but to do that we have to access to farm conditions such as systems, barns, or feeding system, feeding information, and we don't have this information. In Spain, also, of course, we can assume that the cows are more acclimated to heat stress than in the other situations. For conception rate, the thresholds were much more homogeneous, but we observed, as I said, a steeper decline in the French and the Dutch Holsteins than in the French Montbéliard and the Spanish Holsteins. So for Spain, again, we can imagine that acclimatation and the better equipment may explain these results. And in Montbéliard, we can also assume, imagine that there are differences in genetic abilities. So to conclude, we observed a negative impact of increasing THI on all traits. So this is why it's very important to work on that and to include these traits in the breeding programs. We observed consistent patterns between breeds and countries, but with some variations of thresholds, particularly for production and somatic cell counts. But the low threshold, as I said, may be explained by things that are not related to heat stress, so we have to be careful with that. And this is why on the genetic studies, the thresholds that we kept, and so to define heat stress, are much higher than the threshold that we observed here. So in any way, traits on heat tolerance can be defined using combining performances and weather data. And as I said, the pattern of the curves depend on the traits. That means that the trait heat tolerance is very complex, and we should combine all this information to define what is a heat-tolerant cows. So I wanted to thank Remigen that financed this program, and thank you for your attention.